morning to all. Today we are going to discuss about projections of solids. So previously we know how we will project the lines, project the planes like that. Now we are going to discuss about projection of solids. So before going to projection of solids, we have to know what is the solid and how many types of solids are there. So solid. A solid is a 3D object which is having length, breadth and thickness bounded by the surfaces which may be either plane or curved. So it is a 3D object having length, breadth and thickness bounded by some sort of surfaces. They are classified as polyhedron and solids of revolution. So in polyhedron we are again it is classified as prisms and pyramids. In solids of revolution, cylinder, cone, etc. We are going to discuss about these types of solids. So polyhedron. A polyhedron is a solid bounded by plane surfaces. So we can see here a triangular prism is there. Here bottom face and top face is a plane, and sides also we are having planes. So plane surfaces is a polyhedron. So in that we are going to discuss about prism. So prism is a polyhedron formed by two equal parallel regular polygon end faces connected by side faces which are either rectangles or parallelograms. So see here there are four different types of prisms are there: triangular prism, square prism, pentagonal and hexagonal prism. Here end faces, that is bottom and top end faces, are of same polygon. So here triangle, bottom triangle and upper triangle. These two are connected by rectangular faces. So end faces are triangles and rectangular faces are connection between these two triangular faces. So this forms a prism. So the center point of the two bases or end faces are also called as bases. So center points of two bases are, if they joined, we will call it as axis. So this is base and this is base edge, and this joining between two bases is rectangular faces. So from each point we can join. Here it forms a rectangular face. Here also we can see the rectangular face. In triangular prism also we can see rectangular face. So in triangular faces, triangular prism, 3 rectangular faces are there. Square prism, 4 rectangular faces. Like that, depending on the number of sides of the polygon, we are having a number of faces. Next, coming to pyramid. Pyramid is a polyhedron formed by a plane surface as its base and a number of triangles as its side faces, all meeting at a point called vertex or apex. So see here, this is the base. So here we are giving a square base. So square base is all the corners of the base are joined to a single point called apex. So these corners joining to the apex will form a face, that is a triangular face. In prism we saw rectangular faces. In this pyramid we will have triangular faces. The edge of the triangular face is called slant edge and edge of the base is called base edge. So similarly we can see pentagonal pyramid and hexagonal pyramid. So in each thing we are having triangular faces. Here triangular face is there, here one triangular face is there, and they are showing the slant edges also. So the dimensions, the parameters which we are going to see on which we have to identify on prism are apex and base are the main things. So from each corner of the base it will go join the apex, and the corners which will join the apex is triangular face and this edge is the slant edge. So these are the basic parameters in pyramids. So next, coming for solids of revolution. Solids of revolution is some plane figures revolved about one of their sides. Then it is called solids of revolution. See here a cylinder. When a rectangle is revolved about one of its side, it generates a cylinder. So here we can draw a rectangle. That rectangle is revolved 360 degrees. So it forms a cylinder. Similarly, for cone, a right angle triangle. So if we join the line here and here, we will form a right angle triangle. That right angle triangle is revolved along its side. So this is called cone. So cylinder and cone. So if we consider in a cylinder, two bases are there, and in cone apex and circular base is there. So cone is nothing but a circular pyramid. cylinder is nothing but a circular prism. Next. So till now we discussed about types solids and types of solids. Now we are going to project the solids. So how the solids are placed? So solids are placed in different positions. It is mainly based on the axis of the solid. The axis of the solid, whether it is with respect to HP or VP, how it is, it defines the position of the solid. So basically there are three different positions of solids. Axis is perpendicular to HP or VP, and axis is parallel to either HP or VP but inclined to other. That means if it is parallel to HP and inclined to VP, or parallel to VP and inclined to HP. So similarly inclined to both HP and VP. So in first point, axis is perpendicular to either HP or VP. In second point, axis is inclined to either HP or VP. In third point, axis is inclined to both HP and VP. So we are going to see how the different positions will be. So first, axis of the solid is perpendicular to HP. So we are considering only the axis is perpendicular to HP. So it will form the base position of the solids. So here see, a solid is placed on HP with its axis perpendicular to it. So if it is perpendicular to HP, axis is perpendicular to HP means the base will lie on HP. So base is lying on HP means when the solid is placed with the base on HP, in the top view we will get its true shape. True shape of the base we will get in top view, because top view means we are seeing from above, so we are getting the true shape of the base. So this is the basic configuration. So axis, if axis is inclined to axis is perpendicular to HP, then the true shape of the base will lie in top view. So similarly, axis is perpendicular to VP. If like that, if axis is perpendicular to VP, the true shape will be projected in front view. So in previous slide, if axis is perpendicular to HP, true shape of the base is in top view, and axis is perpendicular to VP, true shape of the base is front view. Next, coming to axis of the solid inclined to one plane. That is, here we are showing axis inclined to HP and parallel to VP. So if it is placed on HP with axis inclined to HP, the portion of the solid depends upon the type of solid. So if we are taking a prism, then it will lie on one of its base edges or one of its corners on HP, or rectangular faces of HP, lie on rectangular faces of HP. Similarly, if the pyramid is placed on HP with its axis inclined to HP, then one of its base edges will lie on HP, or base corners will lie on HP, or the triangular faces will be on HP. So next, coming to solid with axis inclined both to HP and VP. So if both to HP and VP inclination is there, then we have to draw the projections in three stages. So the solids are placed first in simple position. In first stage we have to place in simple position, and in second stage we have to consider only one inclination and we have to draw the positions, and in third stage we have to obtain the both inclinations to get the final position. So this method is called change of position method or three-step method. So we are going to see steps involved in solving three-step method. So in this three-step method, we have to assume, first we have to assume solid is standing on a plane, or the angle is inclined. So if it is solid is standing on a plane, or the axis is perpendicular to HP. So if it is inclined to HP, so first inclination, axis, if it is given inclined to HP, assume that it is standing on HP. If it is inclined to VP, assume that it is standing on VP. So already we have discussed that if the solid is standing on HP, then the true shape of the base will lie on top view. If it is standing on VP, the true shape of the base will lie on front view. So according to that, if it is inclined to HP, we have to assume it is standing on HP. If it is inclined to VP, assume it is standing on VP. So we have to start this with this view, then its other view. So if it is standing on HP, the true shape of the base is in top view. The other view will be a rectangle if it is a cylinder or prism, or it is a triangle if it is a cone or pyramid. So we can see here, first position, the solid is placed on HP. So the true shape of the cone, that is circle, base circle, is in top view. Then if it is a cone, so in the other view we are getting a triangle. So this is the first position. Similarly, if it is resting on VP, in front view we will get the true shape, and the other view will get a rectangular face. So for prisms or cylinders, in other view you will get rectangular face. In a cone or pyramid, we will get a triangular shape in other view. So coming to the next step, consider solids inclination. So first inclination we have to take, and we have to draw the front view and top view. So here the first inclination we made, and we tilted this position. This position is tilted, and from that we have to draw the projections, and from this front view we have to draw side projections. The meeting points will join by lines or curves. So this will form the second position. In the third step, the other inclination we have to make. Here axis is inclined to HP, that is shown. Next, the axis is inclined to VP. So third step is, both inclinations are there in this three-step method. So first inclination we have shown here. The other inclination we have to shown in VP, that is in top view we have to show. So this top view is tilted according to the inclination given. So here it is a horizontal axis that is tilted by some angle. So from this we have to draw the projections, and from here we have to draw the projections, so that we will obtain the final front view. So this third position will give the final top view and front view of the object. So like that we have to consider the steps, and we have to draw the projections of solids. So important steps are, first one, if it is inclined to HP, assume it is standing on HP. So if it is standing on HP, its top view will be the true shape. Similarly, if it is inclined to VP, assume it is standing on VP. If it is standing on VP, its front view will be the true shape. So with this assumption, we have to draw the first position. Then we have to place the inclinations. And already we have discussed that if it is inclinations, it may lie on one of the corner, or one of the edge, or one of the generators. Here it is resting on corner. So we are tilting such that one corner will be on XY plane. Here also it is resting on corner. So this corner we placed on XY plane. So similarly, if generator is resting on HP, means this total generator we have to we have to draw on XY plane. So like that we have to consider the positions, and we have to draw the projections of solids. So by viewing this, we will solve a problem in tomorrow's class. Thank you.